Explain what effect increasing the pressure would have on the rate of attainment and the equilibrium yield of ammonia in the Haber process. Okay, so there's two things we've got to talk about here. Rate of reaction and then the equilibrium yield. Rate first. Okay, so if we increase pressure, that squashes particles closer together, moves particles closer. If we move particles closer, we get more collisions. That gives us more collisions between reacting particles. More collisions between reacting particles speeds up the rate of reaction. Speeds up rate. Okay, equilibrium yield. Now to do this, there's always three rules I want you to remember about equilibrium yield. Okay, one's about temperature, a third's about concentration, but the second one here is about pressure. Increasing the pressure on a reversible reaction with reactants and products are gases favours the side of the reaction with fewer gas molecules. Okay, so we have to look at the balanced equation here. So let's have a look at the balanced equation. Nitrogen with 3 hydrogens reacts to make ammonia, 2 ammonia molecules. So we have to count the number of molecules on the left and the right. Now, there's no number before the nitrogen there, so there's a big number 1. So to count the molecules, we count these stoichiometry numbers, these big numbers. So there's 1 and 3 equals 4 molecules on the left. On the right, it's just the one product, there's 2 molecules. So this side, the right-hand side, has less molecules. So increasing the pressure, bring us back, increasing the pressure favours the side of the reaction with the fewer molecules. Okay, so that's what we need to write here now. So we write that rule out. Increasing the pressure favours the side of the reaction with fewer molecules. Increasing the pressure here increases the yield. Why? Because there's less molecules on the right. Because there are less molecules on the right of the equation. Okay, all these questions on aylsham high chemistry.com.